let's do composition. All right, so finding the composition of a function. So composition sometimes can be a little bit challenging until you get the hang of it. So another way that sometimes you see composition is they call it f of g. Like it looks like that, looks like fog. And some people say, oh, that's kind of funny because like composition's so hard to understand, like it's foggy. Yeah. So I thought composition was a little difficult too when I first started, and then you get the hang of it and it's not so bad. So I'm going to try to show you guys the way I find is easiest, and if it doesn't work for you, then we'll find another way. So when I deal with composition of functions, I always look at the outside first. So this says I'm going to take f, right, and inside of all the x's for f, I'm going to put g of x. So when I try to relate this back to function notation that I learned in Algebra 1, so in Algebra 1, you'd see something like this, like f of 2, right? Like if I said it was f of 2, what would you do with that 2? So the 2, you'd put an x in here, right? And you say 3 times 2 minus 2. So we're going to do the same thing, but we're going to put g of x in it. So what was your question, TJ? Yeah. So now, so what I like to do is I like to start with the one that's on the outside. So the one on the outside is f. So then I look at f. And they say f is 3x minus 2. So instead of putting the x, I'm just going to put the parentheses. So I start with f. So I say 3, then x, right? Put the parentheses, minus 2. So then I know inside those parentheses is going to go g of x. So g of x in this case is x squared. So now inside those parentheses, I put x squared. And then I just perform any math that I have to do. So this one, it's just going to be 3x squared minus 2. So, and of course, that would be my new function h of x. So then I have to think about the domain. Well, what is the domain of this function going to be? Well, it has no square roots and it has no fractions, so the domain is just going to be all real numbers. So we're going to do the same thing with the next one. The next one says we're going to take g, and then in place of the x of g, we're going to put f of x. So g is x squared, so I say, okay, well that means h of x is going to be g, so x squared, so I put parentheses squared, right, for x squared, because that's what g of x is. And then inside the parentheses of g of x, I'm going to put f of x. F of x is 3x minus 2. So then now I'm just going to perform the math. So now that says I'm going to take that and square it. So that means I have 3x minus 2 times 3x minus 2. And then we're going to use the distributive property. So 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. Negative 2 times 3 is another negative 6x. And then negative 2 times negative 2 is positive 4. And then combine like terms, you get 9x squared minus 12x plus 4. So then we look at the domain. Well, once again, we have no fractions and no radicals or fractional exponents, so the domain is just all real numbers. So I want you guys to try to go ahead and do C and D, and then we're going to do E and F together.